today what we want to do is we want to be able to determine graphs and kind of characteristics of graphs by looking at intercepts and symmetry. We start with intercepts. So if you have some type of a function, if it crosses the x-axis, we call this an x-intercept. And the spot where it crosses the y-axis, we call that the y-intercept. And I know that people sometimes have negative views of graphing. You're going to become very efficient with graphing in this class once we get to chapter 2. We're currently still in chapter 1. When we get to chapter 2, you're going to be really, really good at it. Okay? And what's interesting about the x-intercept is that you already know one of those values. The x-intercept has an x value and a y value, and it happens to be that the y value is 0 all of the time. So if you want to find the x-intercept, plug in 0 for y. Y-intercepts are similar, except in that case, the x value is always 0. So plug in 0 for x. Once you find those points, you can generally sketch the graph then pretty quickly. I like to organize my work in a table. So what I do is sorry about that. I like to create x, y, and I just drop a 0 and a 0 and solve from there. That helps me organize my work and keep track of it so I can see it as I plot it. Very efficient way. You step onto an ACT, you need to determine the graph of something. A lot of times looking at x and y intercepts, very helpful way of going about it. So we're going to find the x and y intercepts here. This one is everything to the first power, x to the first power, y to the first power. And that tells us that the shape it makes is a line. And so I'm going to plug in 0 for x. I'm going to plug in 0 for y and see what I get. Notice when you plug in 0 for x, the x just disappears. What would the y value need to be in that situation to make the equation true? Negative 4y times? Negative 2. There we go. And then, if you went ahead and made your y, or your y value 0, you can see that x is just 8. So that little trick told us right away that we have x and y intercepts of negative 2 and positive 8. So I plot negative 2 for the y. I plot 8 for the x. I draw my line. Simple enough? I'm going to sketch number 2 on the same set of axes. If I make x 0, notice that the x's disappear, leaving me with just negative 8. So once again, 0 is a great number to plug in. We've been using 0 a lot in this unit. Continue to use it. And then for the x value, well, I've got to plug 0 in for y. And notice it's a little bit more challenging to see what the solution would be there. If I plug in 0 for y, I have to factor this in order to figure out what the y or x-intercept would be. And notice since it's an x squared, we're going to come up with 2 solutions. I have both positive 4 and I have negative 2. Since it's x squared, you got an idea that it's going to make the shape of a parabola. I mark negative 8 on the y-axis, positive 4 on the x-axis, and negative 2 on the x-axis. And I've got that shape. It's not a perfect graph, but it's pretty decent. I mean, if you were to graph it on a calculator, that's about what it will look like. Okay. So, x and y intercepts, efficient ways of producing graphs. Try number 3 on your own. Okay. Find the x, y intercepts, see if you can sketch a graph, compare it to the person next to you, see what they came up with. Okay, hopefully you came up with 9 for your x value for the intercept, and then y would be positive and negative 3. So as we sketch this, I'm going to go by 3s. So 3, 6, and 9. What kind of shape did you notice about this? What did you notice about this shape? It makes a parabola, but
Sideways.
Sideways. Very good. We got positive 3, we got a negative 3. 9 is the x-intercept. As you can see, it heads off to the left. So maybe the first time in your class you've drawn a sideways parabola. We're going to get to examples like that come up later on as well. Our last example is this guy before we move on to symmetry on the back. Notice I have both x squared and y squared. We kind of saw that with circles yesterday. We saw x squared and y squared. If I plug in 0 for x, I get 4y squared is 16, or y squared is 4. If I have y squared, how many solutions will I have? 2. So as you take the square root, you get both a positive 2 and a negative 2. Make sure you list both. Listing 1 is not enough. And then if you plug in 0 for y in this situation, okay, we get x squared is equal to 16. Notice again 2 solutions of 4 and negative 4. It's okay if we don't know the shape ahead of time. We just plot positive 2 for y and negative 2 for y. We plot positive 4 for x and negative 4 for x. And there's my shape. An oval. An ellipse. Notice how the equation was similar to a circle from yesterday, but it's a little bit different. And again, on the test, I'll be asking that you can find the x and y intercepts. What your graph looks like, that's up to you. Okay, what I want you to do is talk to the person next to you. How would you describe symmetry to somebody? And can you think of something in real life that is symmetrical? Go, talk. What's symmetry and what's symmetrical?
I had an idea about that.
Can you think of something that's symmetrical?
I don't want to. The wheel of a car.
So symmetry is something the same from one side to the other. Can you think of something that's symmetrical?
Whiteboard.
Sure, whiteboard, symmetrical. What'd you say?
I said a circle.
Circle, symmetrical, good. How about your face?
No, probably not.
Face seems like it's close to symmetrical, isn't it? They have these apps where you can actually, model one side on the other. You actually look fairly different. Your face, even though you would seem like you're symmetrical, you're not that symmetrical. But symmetry is something important. Nature likes to grow in symmetry. Symmetry is something we can test within mathematics, and I'll show you how to do it. It's really quite simple. This went pretty well last hour. But this equation that you see here, x equals y squared minus 4, it is symmetrical about the x-axis. And the graph, we won't take a lot of time to produce a graph in order to save time. I'm just going to draw it. But that's what that graph looks like. It's a horizontal parabola that is symmetrical about the x-axis. And what that means is if I have a given x value, that x value corresponds with a y value that's negative and a y value that's positive. So in other words, no matter what y value I choose, whether I choose a positive y or a negative y, it corresponds with the same x. So how do we test for symmetry? Simple. We just plug in negative y. And watch what happens. I get x equals to, and this is the work I'm going to want you to show on the test, I go parentheses negative y squared. Whenever we substitute something in, we like to use parentheses. What happens if you square a negative?
It makes it
Positive. So we get x is y squared minus 4. Is that the same as what I started with?
Yeah.
It is. So therefore, we know it's symmetrical about the x-axis. This one happens to be symmetrical about the y-axis. Right now, you would struggle to come up with what this looks like on your own. As we go through this class, I will eventually teach you how to sketch this graph as quickly as I am. It happens to look almost identical to that. If you were to put that in your calculator, that's what you come up with. And what's interesting about when it's symmetrical about the y-axis is if I have a y value, that corresponds to some x value, and the same negative x value right on the other side. So what that means is it doesn't matter which x value I plug in, I get out the same y value. So for this example, we plug in negative x. So I have y equals. Again, I use parentheses when I plug in the negative. What happens when you take a negative to the 4th power? Yeah, if it's an even power, it's going to make it positive. An odd power will be negative. So I have positive x to the 4th minus 3 times a negative x squared is a positive x squared. Notice how that is the same as which we started, which means it is symmetrical about the y-axis. And the one that I think is most confusing for people is the origin. I think the best way to describe symmetry about the origin, this graph looks like this. And symmetry about the origin can be explained in this way. If you were to rotate the object 180 degrees, it would look identical. Flip it 180 degrees, looks the same. And in this situation, you plug in negative x and negative y. So we're going to replace y with negative y. Notice I use parentheses. Then a negative x cubed. And then a negative x. This y is just negative y. What happens if we cube a negative? Is it positive or negative?
Negative.
So I get a negative x cubed. And then we have minus a negative x, so a plus x. Is that the same as what I started with? Sure doesn't look like it, but if we were to multiply through by a negative 1, we get a positive y equals positive x cubed minus x. Is it now the same as what we started with?
Yeah.
Yes. So this is symmetrical about the origin. You're always allowed to multiply an equation through by a number, and it does not change. An inequality, we have to change the sign. So we'll play the guessing game. Turn to your partner, and I want you to not work this out. I simply want you to decide, do you think that that is symmetrical about the x-axis, y-axis, the origin, all of them, or neither? You got 5 options. Don't actually work it out. We'll work it out together. Just take a guess. You got 20 seconds. Come up with your guess. Go.
All around. No.
Anybody feeling bold?
Sure.
What do you think?
I think that the first one's none of them.
First one's none of them.
None.
Okay, all right. Let's see if he's right. We plug in a negative y. So I have 2x, and a 3 times a negative y is 0. So I plug in my negative for my y. As I work that out, it's just 2x minus 3y is 0. Is that the same as what I started with? No. So it's not symmetrical about the x-axis. So far, Keaton is correct. Now I'm going to plug in a negative x to determine the y-axis symmetry. 2 times negative x plus 3y is 0. Or negative 2x plus 3y is 0. Is that the same as what I started with? No, it's not. Keaton is still correct. Keaton, how does it feel to be right so far?
Pretty damn good.
All right, good for you. I like that you interjected a cuss word into that. It fits you well.
It does.
It does. And thank you for keeping it PG-13, not R-rated.
You're welcome.
Our last one. 2 times negative x plus 3 times negative y is equal to 0. For the origin, I do both of them. Notice as I do both of them, I have a negative 2x, I have a minus 3y is equal to 0. Is that the same as when I started? If I multiply by negative 1, I get 2x plus 3y is 0. So it is symmetrical about the origin. Keaton, how does it feel to be wrong at this moment?
Awful.
Okay.
Just awful.
We thank you for putting forth a guess, though. That shows you have bravery. We're not talking 9/11 bravery, but bravery in math class. We'll take it. Okay, talk to the person next to you. What do you think about this one? X-axis, y-axis, origin, all of them, none of them? What do you think? Take a guess. Go. Make your guess. All right. Who's bold here? Keith was bold last time. Somebody want to put forth their guess? Ben, what's your guess?
None of them.
None of them, he says. All right, let's check to see if Ben is right. We switch the y to negative y equals 3x minus 5. Ben didn't sound too confident there, did he? We got negative y is 3x minus 5. Is that the same as when we started? No. Ben is correct so far. For the y-axis symmetry, we replace x with negative x. We have y is 3 times negative x minus 5. Or y is negative 3x minus 5. That is not the same either. Ben, how's it feel to be right on the first two so far?
I don't know.
You don't know what it feels like?
I don't know if I believe.
You're not feeling like a big dog yet? Okay, all right. Well, let's check the last one. He's got negative y is equal to 3 times negative x minus 5. So we work through those negatives. We get a negative y is equal to negative 3x minus 5. That is not the same. But what if we multiply through by negative 1? Is it now the same? No. Ben, you're correct. No symmetry at all. How's it feel?
Pretty good.
All right. Hey, I was watching the football highlights today, and I saw on Brecken's return. Did you guys see Evan lay out that guy right at the end?
That was on mine.
Oh, that was on yours. Okay, it was on one. I saw one of them. I saw, yeah. It wasn't a blindside hit either. I mean, you got it right here. So good, good. They cart him off after that. Okay. All right, make your last guess. X-axis, y-axis, origin. All of them. None of them. What do you got? Make a guess. Talk to your partner. Go. Make your guess. Yes. Okay. Van Keaton and Ben put forth a guess. Somebody else? Show me your boldness.
John.
John, what do you think, dude?
I guess all of them.
You're guessing all of them. Nice sunglasses, man. Every day. You don't miss a beat. 2x squared plus 3 times negative y squared is equal to 4. I like the way John thinks because John sees that you got both squareds. And he knows that squareds are very friendly at getting rid of the negatives. So he can see that the first one is, without a doubt, yes, it is symmetrical about the x-axis. He looks at the second one. 2 times negative x quantity squared plus 3y squared is 4. When you square that negative, it does become a positive. John, how's it feel to be right on the first two?
Just a guess.
And the last one, hopefully it feels pretty obvious right now after you've done the first two that if you're squaring both of them, the negatives will disappear. John is correct. It is symmetrical about all 4 of them.
Good job, John.
Way to go, Big John. Rocking the sandals and socks today, I see. No boots? You're no more a boot guy.
Boots aren't made for walking.
Boots ain't made for walking. Hey, take out your homework.
Oh, I got
Okay, so this 1.8 that talks about symmetry and x and y intercepts, just please note that the first, so this worksheet used to be 2 pages front and back. It's now just 1 page front and back. So I try to dial down your problems to just the essential things you need to know how to do. It says test the following for symmetry. So symmetry is the first 6 problems, okay? And then, if you flip over to the other side, that's where you find x and y intercepts. It says to try to sketch a graph. The graph doesn't have to be super accurate, just a quick little graph, okay? Quick little graph, okay? Raise your hand if you got some math to do this weekend. Tell the person next to you, when are you doing math this weekend?
Sundays for football and senior pairs. Saturdays.